All right, people, we got a fresh batch coming through. iPhone 15 Pro Max, titanium blue. Let's keep it tight, keep it clean. This is precision work. Line supervisor here. Station Alpha, you hot? Copy that. We're green and ready. Conveyor's running smooth. Station Bravo, what's your status? Bravo's locked in. Glass panel station, prepped and standing by. Charlie station. Charlie's good to go. Camera module ready for integration. Perfect. All right, let's roll. Quality check on deck, people. 0 defects. Apple doesn't do recalls. Remember that. Got reputation on the line here. Titanium frame incoming now. Serial number Tango 729R Alpha. Scanning the barcode. Scan confirmed. Frame authenticated. Move it to the prep station. Nice and easy. Frame's on the jig now. Checking tolerance with the laser micrometer. What's the read on that? 0.02 millimeters. Well within spec. We're green across the board. Beautiful. Proceed with cleaning protocol. Initiating ultrasonic bath. Timer set for 90 seconds. Anti-static brush standing by. Affirmative brush ready. No particulates detected on visual inspection. This baby's gotta be surgical room clean, understand? One speck of dust, and the whole unit's compromised. Bath cycle complete. Frame coming out now. Drying under nitrogen flow. What's the nitrogen pressure reading? 2.5 C, right on target. Perfect. Move it to assembly station 1. Keep that flow going. Station 1 here. Logic board with the A17 Pro chip, ready for placement. That's the beast, right? 3 nanometer process. It's correct. 19 billion transistors on this little guy. Absolutely insane engineering. All right, what's the placement accuracy looking like? Robotic arms calibrated, tolerance set to 0.01 millimeter. Let's do it. Arm extending now, board descending. Contact in 3, 2, 1, board seated. Give me a pressure check. 0.5 newtons. Perfect contact. No voids detected on the sensor array. Lock it down. Thermal paste applied, even spread confirmed under the microscope. Heat sink descending now. What's the torque reading? It's 0.35 newton meters. Spec calls for 0.3 to 0.4, so we're golden. Secure those screws. Screw 1, torque to spec. Screw 2, torque to screw 3. Torque to screw 4, torque to screw 4 torqued. All green lights across the board. Logic boards in and locked. Run the power test. Stand by. Connecting diagnostic cable now. Power on. Board initializing. Waiting for boot sequence. We got boot. Chips alive. All 16 cores responsive. GPU-S firing on all cylinders. Neural engines online. Beautiful work, people. Temperature readings nominal at 23 Celsius. Voltage rails all stable. This thing's purring like a kitten. Next station, let's keep the momentum going. Station 2, checking in. Old panel ready for integration. Promotion display. 120 Hz refresh rate. Handle that thing like it's made of glass? Oh wait, it is. Ha! Copy that. Panel coming in now. Checking for dead pixels under UV light. Any defects visible? Negative panel's absolutely flawless. It's 24 million pixels, all firing perfectly. 0 dead zones, 0 discoloration. That's what I like to hear. What's the status on the adhesive layer? Pre-applied at the factory. Thickness verified at 0.1 millimeter. Even distribution confirmed under inspection. Alignment marks ready. Laser guides are active. Panel positioned above chassis. Margin of error set to 0.05 millimeters. Drop it nice and slow. Lowering now, easy does it. Contact made, adhesive activated on touch. Applying even pressure across the entire surface. What's the pressure reading? 2 kilograms per square inch. Holding steady for 30 seconds as per protocol. Timer's running. Any bubbles forming? Negative seal is absolutely perfect. 0 air pockets detected. Gorgeous work. Displays locked in tight. Run the touch test now. Multi-touch diagnostic initiated. Testing all zones systematically. Top left quadrant green, top right quadrant green, center zone green, bottom zone green. Responsiveness measured at 1 millisecond latency. Pressure sensitivity calibrated. We're good to go. Display assembly complete. Roll it to the next station. Station 3 here. Camera module incoming. 48 megapixel main sensor, LiDAR scanner, 5 times telephoto, the whole 9 yards. That's the money shot right there, literally. Those lenses cost more than most people's monthly rent. No joke. Main lens has 7 elements. Telephoto's got 6 elements with that fancy periscope prism design. Be careful with that prism. If it's off by even a micron, the autofocus system's completely toast. Roger that. Robotic precision arm engaged. Camera module secured in the gripper. Moving to chassis now, real slow. Descending, I can see the alignment pins, guiding it in, guiding almost there. Pins seated perfectly. Lock it in. Torque driver engaged. Screw 1 at 0.25 Newton meters, green light. Screw 2, 0.25 green. Screw 3, same reading, green. Screw 4, locked and verified. Run the full optics test suite. Connecting camera ribbon cable to the logic board now. Firmware loading, initializing all 3 sensors simultaneously. Focus, test running, pass. Image stabilization test, pass. LiDAR calibration complete, pass. Color accuracy test shows delta less than 1. That's showroom perfect. Night mode sensitivity verified. Zoom mechanism tested through full range, smooth as butter. No grinding, no hesitation. Portrait mode depth mapping calibrated. That's flagship quality right there. Camera module integration complete. Next station. Station for checking in. Battery pack incoming. 4-1000-4-100-40-1 million powers of lithium-ion goodness. That's a lot of juice in one package. Handle with extreme care. Lithium-ion doesn't mess around if you puncture it. Copy that. Battery placed on non-conductive mat. Running visual inspection. No bulging detected, no physical damage. Connector pins pristine. What's the cell voltage reading? 3.85 volts per cell. That's nominal range. We're safe to proceed. Drop it in the chassis. Battery descending into the compartment. Connector alignment verified. Making contact now. Click. It's seated. Lock down those retention brackets. Bracket 1 secured. Bracket 2 secured. Adhesive strips making contact. Pull tabs removed. Battery's not going anywhere. Connected to the logic board. Flex cable attached. Connection verified. Run the charging test. Connecting to test power supply. Initiating charge cycle. Current draw nominal at 1.2 amps. Battery management system responding correctly. Temperature monitoring active. Cells at 24 Celsius. Charging curve looks perfect. Battery health reported at 100%. Cycle count 0 as it should be. Disconnect test power. Battery installation complete and verified. This thing's ready to power up and run for days. Move it along. Station 5. Audio components ready. A dual speaker system and haptic engine. These speakers are tiny, but they punch way above their weight class. Setting the bottom speaker first, placing it in the cavity. Alignment's critical here. The acoustic chamber is precisely tuned. Speaker 1 seated, connector attached. Lock it with the bracket, secured. Now the earpiece speaker. This one's even more delicate. Placing it near the display assembly, connector first. Seated and locked. Run the audio test. Playing test tone at 440 Hz. Output verified. No distortion. Frequency response flat across the spectrum. Bass response surprisingly good for this size. Trebles crisp and clear. Now for the haptic engine, this is what makes the phone feel premium. Apple's Haptic engine, linear actuator design. Placing it carefully, this thing's got some weight to it. Secured with 2 screws, torqued to spec. Connect the flex cable. Running haptic test. Initiating click feedback. Nice and sharp. Testing the different intensity levels. Soft tap, medium tap, strong tap. All responding perfectly. The physical feedback is incredible. You can actually feel the difference between notification types. Audio and haptic systems verified and locked in. Next, Station 6 here. Wireless charging coil and MagSafe ring assembly ready. This is the magnetic magic that everyone loves. Coil's got 15 watts charging capability, plus the magnet array for accessories. Placing the coil assembly on the back panel, alignment with the center line is critical. Magnets need to be perfectly positioned or third-party accessories won't align properly. Coil seated, checking position with the alignment tool. Dead center, perfect. Adhesive making contact, pressing down evenly. Connect the coil to the power management board. Flex cable attached and verified. Run the MagSafe test, placing test magnet near the back. Connection strength verified at 1400 grams of force. That's within spec. Charging test initiated with key test pad. Power transfer confirmed. Efficiency at 86%. That's solid. Wireless charging, verified and operational. We're cooking now. Station 7. Rear glass panel ready for installation. Titanium finish, color-matched laser-etched Apple logo. This is where it starts looking like an actual iPhone. Glass panel inspection under light, no scratches, no imperfections. Anti-reflective coating intact. Beautiful piece. Adhesive gasket pre-installed on the chassis perimeter. This gasket's what gives us the IP68 water resistance rating. Checking gasket integrity, no gaps, no tears. Continuous seal all the way around. Lower the glass panel, alignment guides active, panel descending, logo orientation verified. Contact made, now we apply pressure, need even distribution across the entire back. Using the pneumatic press, pressure set to 15 psi, holding for 45 seconds to ensure full adhesion. Press released, checking the seal visually. Perfect contact, no light bleeding through the edges. Run the pressure test. Placing unit in the vacuum chamber, pulling negative pressure to simulate 2 meters underwater, holding vacuum for 30 seconds. No air leaks detected, seal is watertight. Water resistance verified, dust resistance verified. This phone could survive a swimming pool and come out smiling. Rear panel installation complete. Now it's really starting to look like the finished product. Station 8 button and switch installation. We got volume rockers, power button, and that action button that replaced the mute switch. These buttons use capacitive sensors now, no actual mechanical movement, which is wild. Placing the volume rocker assembly on the left side rail, alignment pins guide it into position, secured with micro screws, torqued 2.15 Newton meters. Power button on the right side, same process. Action button going in above the volume controls. All 3 buttons seated and locked. Connect the flex cables to the logic board. Testing button response. Volume up, registered. Volume down, registered. Power button, registered. Action button, programmability verified. Haptic feedback synchronized with button presses. The illusion of clicking is perfect. You'd swear these are mechanical buttons. All buttons operational and verified. Next station, Station 9. Final assembly and calibration. This is where everything comes together. Installing the SIM card tray slides in smooth, no resistance. Ejector mechanism tested, works perfectly. Now connecting the final flex cables, display connector, battery connector, camera connector, all seated and locked. Close up the chassis. Lowering the display frame, alignment verified. Pentalobe screws going in around the perimeter. Torque set to 0.8 Newton meters. Screw 1, 2, 3, 4, 5, 6 all torqued and verified. Unit is now fully sealed. Power on sequence initiated. Apple logo appears on screen. Boot time measured at 12 seconds. iOS loading. Running full system diagnostics. CPU stress test, pass. GPU benchmark, pass. Memory test, pass. Storage read-write speed, pass. Wi-Fi radio test, pass. Bluetooth test, pass. 5G modem test, pass. GPS satellite lock, pass. Face ID calibration in progress. Infrared projector mapping. 30,000 dots projected. Face recognition system trained and verified. All sensors calibrated. Accelerometer, gyroscope, magnetometer, barometer, all reading correctly and within tolerance. A device is fully operational. Final station, quality control, and packaging. This is the last checkpoint before this phone goes to a customer. Running visual inspection under bright lights. Checking for any cosmetic defects, scratches, dents, misalignments. Nothing detected. Unit is pristine. Color matching verified against reference sample. Perfect match. Running the drop test simulation data. Unit design passed 40 drop tests from 1.5 meters. Screen intact, chassis undamaged. Structural integrity confirmed through testing. Device passed all 68 quality checkpoints. Wiping down the device with microfiber cloth, removing any fingerprints or dust. Unit going into the box now. Accessories included, USB-C cable, documentation, SIM ejector tool, Apple stickers, box sealed with the pull tab, serial number registered in the system. This iPhone 15 Pro Max is officially ready for shipment. From raw titanium to finished product in 18 minutes of pure precision engineering. That's how Apple does it. Next unit rolling in. Let's keep this line moving, people. We got millions of customers waiting. clear for transport.